In this lesson, we will investigate effects of the value of a upon the graph and its elements. For this lesson, we assume that value of a is greater than 0. Let's start with the base graph of f of x is equal to x squared, and then we will compare this graph with that of graphs with varying values of a. So draw the graph of f of x equal to x squared, and then compare with g of x equal to 2x squared, because in this case a will be greater than 1, and we will see if it affects graph of base function f of x is equal to x squared in any ways. And h of x equal to 1 by 2 x squared, in which the value of a is between 0 and 1, and we will see how the graph of base function is affected by changing the value of a and making it something between 0 and 1. So the graph of the base function, from the table of values we have the ordered pairs. This one is 0, 0, and the next ordered pair is 1, 1, 1, 1, and the next ordered pair is 2, 4. So 2, 4 is right here, 2, 4, and the next pair is 3, 9. 3, 9 is right here. And on the negative side, for negative values of x, the point is minus 1, 1, and minus 2, 4. Minus 2, 4 is right here. Minus 2, 4, and then minus 3, 9. Minus 3, 9 is right here. This is minus 3, 9. And now for drawing the graph, we join these points with a freehand curve. So let's draw the graph as best as we can. But this is the graph we get by joining these points with freehand, and the equation associated with it is f of x is equal to x squared. F of x is equal to x squared represents this curve. Now, when value of a is changed and the value of a is not 1 anymore, like in g of x, a is 2. From the table of values, we see that values of y are multiplied with 2 when compared to the graph of f of x is equal to x squared, because the rule of transformation is now 2x squared. So whatever were the values of f of x is equal to x squared, we have multiplied with them with 2 and listed them under the table of values for g of x is equal to 2x squared. And now, plotting those values, we are going to write these values. 0, 0 is 1 point on this graph, and instead of 1, 1, now it will be 1, 2. So 1, 2 by doubling y value here, and the next value we'll have is, so if we plot this value here, and 2, 4 will become 2, 8. So 2, 8 will go right here. 2, 8. And 3, 9, in which pair the 3 is value for x and 9 will be doubled, that will become 18. So now we are looking for the point 3, 18. So on 3 and 18. So here will be 16, 17 and 18. That is right here. And on the negative side, this will be minus 1 and 2. Minus 1 and 2 is right here. And next point is minus 2, 8. So that will be right here, minus 2, 8. And the next point will be minus 3, 18. Minus 3 and 18 will be right here. So this is the point 3, 18. And this is minus 3, 18. And this is point minus 2, 2, 4, 2, 4. And this is minus 2 and 4. And this is 1, 2 on this side and minus 1, 2 on this side. And now we visualize a graph through these points just like before. So let's start with this point and bring the graph through this point, continuing this curve to pass through the next point and then touching the 0. And now we will continue it on the negative side here, and this way it will now pass from minus 2, 4, and from minus 2, 4 onward it keeps going to meet the point minus 3, 18. So this is new graph, and it is represented by the equation g of x is equal to 2x square. So this is a stretch in the graph whenever the value of a will increase beyond 1, like 2, 3, 4, 5, the graph of the function will stretch and it will become narrower and narrower closer to y-axis. So this is y-axis. Now let's see if the value of a was equal to 1 by 2. It means if it is between 0 and 1, what happens to the graph? The graph, and for this we have a separate table of values. For h of x is equal to 0.5 x square. Comparing to the base graph, minus 3, 9 was the first value. Here the first value is minus 3, 4.5. Clearly the values of y are now being multiplied with 1 by 2 or 0.5. So they will be reduced by 1 by 2. So now let's take a look on those values. And here the vertex is still at origin because 0, 0 is a point on there. And if we take a look on the positive values, instead of 3, 9, now we will have 3, 4.5. So 3, 4.5 will be right here. This will be the point here, that is 3 and 4.5. So that is this point. And 1, 2 will become, so here what was the point on the original graph? The original point had the graph. So let's take a look. Minus 2, 2. So minus 2, 2. And 2 side and 2 as well. So 2 and 2. That's next point is going to be right here. That is this. So, and origin is right here. So now if we join these points, so this is where these points are going to go. If we join this point, and bring it to region. This is the graph. And on the negative side, where the point -1, is, this is going to be just below that. Here is this point. And -2, 4 is going to be -2, 2. So -2, 2 is going to be right here. And then -3, 9 is going to be -3, 4.5. So -3 and 4.5 will be 1, 2, 3, 4. 4.5 is right here. So now on the negative side, this graph will look like this. And on the positive side, we have this graph already. So this is the new graph, which is called h of x is equal to 0.5 x square. So we observe that when A is our observation, when A is between 0 and 1, graph shrinks. And becomes wider. When A is greater than 1, graph of function becomes narrower, and stretches. So based on this, we can pretty much tell whenever the value of A increases, we can estimate the graph, that how much narrower it will become. And when the value of A falls below 1, we can estimate that how much it's going to shrink or it's going to become wider. If we take a look on the elements of the graph, we will try to find out the elements in comparison. So vertex for f of x is equal to x square, g of x equal to 2x square, and h of x is equal to 1/2x square. Vertex in all these three cases is equal to 0, 0. So for this it is 0, 0, and for h of x it is 0, 0 as well. So the stretch or shrinking, it doesn't affect the vertex. So vertex stays same. This was our first element. The second element is axis. Axis of symmetry. Axis of symmetry also wouldn't be affected, because axis of symmetry for f of x is equal to x square, or g of x equal to 2x square, and for h of x equal to 1/2x square. Either way, whenever we want to find axis of symmetry, we always take the square term equal to 0, and that will give us the axis of symmetry. Here the square term is x square equal to 0. So this means x square is equal to 0, means x equal to 0, which is equation for y-axis, which shows y-axis as axis of symmetry, which are also called axis of parabola. So same thing here, 2x square equal to 0 implies x equal to 0, which is y-axis again. So no change. Again here 1 by 2x square equal to 0 implies x square equal to 0, means x equal to 0, and this means y-axis. So in all three cases, the axes of symmetry are still going to be the same, so no change there. And third element of the graph is, let's talk about the focus. Focus for f of x equal to x square, f of x is equal to x square, g of x equal to 2x square, and h of x is equal to 1 by 2 x square. How we calculate the focus is that value of y for vertex. So y coordinate of vertex, y equal to y coordinate of vertex plus 1 by 4 of the value of a. Value of a. Here for f of x, the y coordinate of vertex is 0. So this is 0 plus 1 by 4 time 1. So this will be 1 by 4. Therefore, focus will be, this means focus is equal to 0, 1 by 4. And if we take a look on this graph of g of x is equal to 2x square, then the focus would be 0 and 1 by 4 time 2. So this will time, the focus will be equal to 0, 1 by 2. And focus for h of x is equal to 0, 1 by 4 of 1 by 2. This means the focus will be equal to 0, 1 by 8. So now we want to find out the directrix. So this is number 3, and now number 4. Number 4, equation of directrix. That is y equal to 0, which is y coordinate of the vertex, minus focal length, which is 1 by 4. So this equation of directrix will be y plus 1 by 4 equal to 0. And here for g of x, this will be y equal to minus 1 by 2. And for h of x, this will be equal to y equal to minus 1 by 8. So in this case, this will be y plus 1 by 2 equal to 0. And here it would be y plus 1 by 2 equal to 0. And equation of number 5, equation of latus rectum in this case is y is equal to y coordinate of vertex, which is 0, plus 1 by 4, the focal length. And here this is again y is equal to 0 plus 1 by 2. And here in this case it's y is equal to 0 plus 1 by 8. So here, sorry, this was 1 by 8. So now this is equation of latus rectum, which can be further simplified. Y equal to 1 by 4, y equal to 1 by 2, and y equal to 1 by 8. And now the sixth, what we need to discuss is the x-intercepts and y-intercepts. For sixth element, x-intercept, intercepts. Just like before, put y is equal to, put f of x equal to 0, g of x equal to 0, and h of x equal to 0. H of x is equal to 0. This means we get x equal to 0. We also get 2x squared equal to 0. And here we get 1 by 2x squared equal to 0. This gives x equal to 0. Here we get x equal to 0. And we get here x equal to 0 as well. This means the x-intercept is 0, 0, 0, 0, and 0, 0. If we want to find out y-intercept, number 7, for y-intercept is just like before. Now this time we are going to substitute, put y equal to 0 for f of x, g of x, and h of x. And h of x equal to 0. So this is equal to 0 and this is equal to 0. Because y in fact is f of x, y is equal to g of x, and y is equal to h of x for any function. This means again 0, 0, 0, 0, and 0, 0 are the y-intercepts as well. In next lesson, we will talk about the stretch and shrinking of graph with negative values of a, and we will also learn to graph just by using vertex and the a value.